Hi, this is Mrs. Vrobel. This is Chapter 3, Matter, Its Changes and Its Properties. This is Part 2. So in this video, we're going to be looking at the following. The first is the law of conservation of mass, and we're going to apply that to chemical reactions. Then we're going to look at what is a mixture and how do we classify it. Then we're going to look at different types of mixtures, homogeneous and heterogeneous. And then lastly, we're going to describe how will you separate a mixture. Okay, the question is, does matter disappear? Well, thanks to the law of conservation of mass, we know that matter does not disappear. It's neither created nor destroyed. So there's no such thing as magical matter. Please note that the mass of the reactants have to equal the mass of the products, and there have been plenty of scientists that have tested this. They've actually contained a reaction within a vessel. They weigh the mass of it before a reaction, and then when they combine it, they weigh the mass of it after. Okay, let's talk about matter. All particles of a sample of matter, if it's identical, we call that material a substance. So this is a vocabulary word that you've looked at with your quiz. So please remember that substances have identical particles. Now, if it turns out the particles are different, so that means they're not the same, we're going to call it a mixture. And I'll show you an example of that in a minute here. Okay, so there's two types of substances. So if the atoms in the molecule are the same, we call that an element. A good example of that is actually my diamond ring. The diamond in the ring is actually an element. Another example is oxygen. So in oxygen that you breathe, every molecule contains two atoms, and those atoms are the same. Okay, now if it turns out that you have more than one type of atom, we call that a compound. Water would be an example of it. So we have hydrogen and oxygen together, and we call that a compound. So for water, there's two hydrogen atoms and one oxygen atom. And if you look at water as a whole, all the water molecules should be the same. Okay, there's what we call an allotrope. Now, allotrope means that we have one type of element and it can form different forms. An example of that would be my diamond ring is carbon, but if you look at a pencil, the lead, we call it lead, it's actually graphite, and the pencil is carbon also, and they are allotropes of each other. Oxygen also has allotropes. The air you breathe is oxygen, or O2, and ozone that we can produce through pollution is another allotrope of oxygen. Okay, let's talk about mixtures. So mixtures, we have more than one substance, and we call that a mixture. Examples of that are air, Kool-Aid, chicken noodle soup. These all combine more than one substance together to form a mixture. Now, there's actually two types of mixtures. If the mixture has the same or uniform throughout, we call that homogeneous. Now, I have a bottle of balsamic vinegar, and vinegar, the type that you use, is actually a combination of water and acetic acid. So this vinegar is homogeneous because if you were to pour it into a glass, you'd see that it's the same throughout. So it's considered what we call a solution. So please remember, anything that's homogeneous, we can also call it a solution. Here are some other examples of homogeneous solutions. You can't have two different phases in that solution. Now, my ring is actually 14 karat white gold. Now, it's a combination of two different metals, and even though it's in the solid phase, it's still considered a solution. Okay, now, if for some reason the sample does not have the same situation throughout. An example of this, my husband, he likes to make Szechuan pepper, and he uses peppercorns and he combines it with sea salt. And this is a homogeneous mixture. So you physically can separate out a homogeneous mixture. I'm sorry, a heterogeneous mixture. Examples of that is if you had salad or ocean water. Even though it's liquid and it looks like there's nothing in there, you could actually pull apart the different pieces of the mixture. A tire, if you take a cross section of a tire, there's different layers to it and different parts to it. And as a result, we can tease apart the different substances that make up the heterogeneous mixture. Okay. So with a mixture, if you have the same phase, we're looking at a solution. If you have a heterogeneous mixture, please note that it's more than one phase. And here we just have two solids that we can physically tease apart. Okay, so let's talk about separation. And this is one that you've probably seen before. We call it filtration. So filtration, we have a funnel, and in that funnel we put a paper, and we can pour a liquid in that paper and it'll retrieve the solid from it, so that way we can tease apart the water from the solid portion. Another type is distillation. Now distillation, you typically have two liquids and they have different boiling points, and as you heat them up, one boils faster than the other, and as a result, the one that boils first, its vapor is collected in another vessel and then separated out from the other liquid. And then crystallization. Crystallization, we use that a lot of times, especially if you're making rock candy. You are crystallizing the sugar out of the solution, and you just need like a seed crystal to start it, and as a result you get a solid substance from the mixture. Okay, other separations. Sublimation. One that you might be familiar with is dry ice. Dry ice, it sublimes. It goes from a solid to a gas. And if we have a combination of substances, the one that sublimes will be removed out of that mixture. And then chromatography. You've seen this many times before, where you have a liquid and you dip a paper that is absorbent, and it allows what the mixture is dissolved in to separate out on that piece of paper. Okay, here's just some pictures of separations. One's crystallization, one's sublimation. This top one here is distillation. And then there's chromatography over here. Okay, in summary, so conservation of mass says that the mass of the reactants has to equal the mass of the products. A mixture is a physical blend of two or more substances. It could be homogeneous, which means it's all one phase, or it could be heterogeneous. And then lastly, we can use separation techniques like filtration, distillation, crystallization, sublimation, and chromatography.